right now sitting around here, but it
Much,
looks
very small.
much more snug, exactly, because they have so much equipment in there as well, right? It's completely crammed. I didn't see the astronauts go in with any luggage, shall we say.
It's already there.
It's already there.
In the orbital module, you can see that there are shelves everywhere, and the cargoes just put well and fixed well in the shelves. Yeah. So today, you know that it is very interesting. The role of the orbital module has already a little bit changed. You know that during the years before, they do have the function that it is a habitable area for the astronaut, because, you know, as I mentioned, the re-entry capital is too small, too narrow. It is not very comfortable to stay there for days, because so in the old missions we conducted several days of mission. For instance, for the Shenzhou 6 mission, the 2 astronauts, Fei Jinlong and Ni Haisheng, stayed in outer space for 5 days in this very narrow space. But today, you know that we've already adopted the faster rendezvous docking. Only we need about 6 hours. So today, the role of the orbital module has already changed. So we hope that we can have more, because it doesn't matter to stay in such a narrow space, because only a very short period, only 6 hours.
Has it ever been used as an airlock?
No, we only use it as an airlock during the Shenzhou 7 mission.
Yeah.
But today we do not, because you know that in Shenzhou 7 mission we do not have other choices.
Because you have to go out to outer space for EVA, then you have to have an airlock.
Yeah.
So people can depressurize and then go out and come back.
And they
so
would
use that as an airlock in the previous missions.
Yes. But today, you know that with the faster rendezvous and docking, it's okay for the astronaut to stay in a so narrow place for this short period. So we can have more chance to install more cargoes inside the orbital module. We've already seen that. Yeah.
They have modified the module. The expert mentioned that the 19 mission they have enlarged the volume so that it can put more cargoes, maybe more apples in board. This is very meaningful for the biological experiments. Some living things. You can put that together with the astronauts
like
inside.
the fruit flies. So Mr. Xu, you were saying earlier that there would be another supply cargo ship going up there
next month.
2 weeks, right?
It's roughly mid-November.
Mid-November.
They're planning to.
And would that be the only supply ship then for the Shenzhou 19, or would be expecting another one a bit later?
The Tiangong 8 cargo spacecraft will both support the Shenzhou 19 crew and the Shenzhou 20 crew, because you know that the interval we launch a Shenzhou spaceship is 6 months, but for the launch of the Tiangong cargo spacecraft, the interval is 8 months. It's different. So for Tiangong spacecraft, it will support 2 crews.
Okay, so the one going up next will be for this crew and the next.
Shenzhou 20.
Okay.
But they have plenty of things to unpack, because they have already got the service module, the orbital module fully packed with bags, and so in the coming 2 weeks they're going to use that time to do a handover job with the Shenzhou 18, and also do a lot of unpacking and packing for the Shenzhou 18 to come back. So they have to do, put the experiments, results, and everything into the capsule of the Shenzhou 18 return capsule, and then wait for the cargoes to come. So it's a time sequence that allow them to work in this period of time with carefully planned schedule.
It doesn't sound like they have much downtime at all. It's get there and it's out to work straight away, isn't it?
Now look at the screen. At this moment, all the rotational platform has already been opened. So we can see the whole fuselage of the launch vehicle itself. You can see the slim body. But still, I should emphasize, at this right moment, there still have some arms connected to the launch vehicle, usually in yellow color. You can see that. And also on these arms, there are cables and pipes connected to the launch vehicle. Still, at this moment, T-minus maybe 20 or 30 minutes counting, still we use the power supply, the electricity from the ground. So to stay, as Yan Song has mentioned, to save the storage battery on board our Shenzhou spacecraft and our launch vehicle. And several minutes later, we will have a very critical step, as we already discussed, the transfer of the power supply from the ground to the vehicle itself.
Yeah, you can see the 2 umbilical cords.
Yes, that's what I mentioned, the arms. Look, in yellow color, connected to the launch vehicle.
Well, we have 20 minutes or so to go until launch, and let's check in again with our reporter Sun Ye, who's there at the Jiuquan Satellite Launch Center. Sun Ye.
骄阳很不容易啊，在如此临近火箭发射的时候，我们找到了一名火箭专家来告诉我们现在火箭的状态怎么样。我们这回请到了徐珊珊老师，他是中国航天科技集团的专家。那徐老师告诉我们，Please let us know about the latest situation about the rocket. 截至目前吧，
and also till now what kind of the work we have done. So let me report to you right now that everything goes well and the rocket actually is functioning well. Right now we've finished all the preparation work for the control system, and also the telemetry work actually is all in the program. So as we know, for the Long March 2F actually is famous for its safety and reliability, and also is improving itself. So this time, what kind of the modification we have? So for this time, compared to the Y18, so we have improved 23 items, and we talk about the structural system and also the techniques, and also for the sealing and also the tightness, and also actually we improved the process of launch. Previously it needed 37 days, right now it's shortened to 30 days. Although it's saved that 7 days a week time, but for the whole system it's improved our efficiency, but also we could tell that for the old system of the rocket, actually we showcase our confidence and our understanding about the whole system. And also we are very glad and also very excited just within 20 minutes we will see Long March 2F Y19 will send Shenzhou 19 to the space.
All right, Sun Ye, thank you so much to you and your guest there. We'll check in with you again later. So lots of improvements made to every new edition of the rocket. Mr. Xu, what would you say are, do you think, some of the most impressive improvements made this round?
Well, I think the engineer has mentioned not only the launch vehicle itself has been improved with 20 plus items, but also
23, right?
Yeah, but also the Shenzhou itself, which is the launch vehicle and the capsule are manufactured by different academies. The launch vehicle is manufactured by the Chinese Academy of Launch Vehicle Technology. The capsule is manufactured by Chinese Academy of Space Technology. So all of them are working together to improve the efficiency, the reliability of the launch vehicle. We know there are changes. If you put a change to, for example, software, there will be a 7% chance that you will have another hiccup with the complete system.
7% chance.
Yeah,
That's very exact.
Yeah. So if you put a change into the system, you have to consider all aspects, and this has been experienced by the Europeans Ariane 5, because Ariane 5 is using the Ariane 4 launch vehicle softwares, but the software was modified in such a way that lots of unfitted software functions were remained in the Ariane 5 launch vehicle. So that had a catastrophic failure for the first launch. So when you make changes, you have to be very careful that this affects the other sides of the complete design. So they made very careful improvement. I think it's very important to increase the efficiency of the launching campaign. She said from 37 to 30 days. That means a lot of manpower saved, and lots of travels, and a lot of logistics, and lots of technical support has been saved. So I think that is a great improvement to the launch vehicle and the whole system for a more efficient launching campaign.
Actually, Professor Yang, there's something I wanted to ask you earlier when we were talking about the IAC. So the theme this year was responsible space activities for sustainable development, right? So how does China's rocket and the Tiangong space station, how does that all fit into this?
Well, you know that during this IAC, we also have many events related to the China's manned space activities and lunar explorations. To have a sustainable future, you know that the leaders of China aerospace, including Mr. Li Guoping and also Mr. Lin Xiqiang, although it's online.
我是领号
Okay, T minus 15 minutes and counting.
Now.
So this is also another milestone for the launch. So the commander on the launch site system are ensuring every subsystem goes okay. Go for launch.
15 minutes ago, Shenzhou 19 launches.
Okay, so everything needs to be checked. Okay. So just during the IC, that the leaders from China Aerospace expressed that the China always recognize the sustainability is a very important consideration of all space activities, including that the debris reduction. You know that for all China's launch vehicles, including this one, and also other launch vehicles, after they come into orbit and send our payload into orbit, we will release the remaining propellants into outer space, and also discharge the battery to reduce it to the greatest extent the possibility of explosion. So this is a very reasonable measure to ensure that we reduce the
passivation.
Exactly.
Yeah.
And also, that to keep the sustainability, that we also have already begun to coordinate with other countries, although it may be a little bit earlier, but the possible collision is this lunar space. You know that there are more, as Yan Song had mentioned. Today, the moon becomes another hot point of the space activities of human beings. So there are more landers, orbiters to the moon. Just during IC, I met some private companies, including the Intuitive Machines from the United States. They provide the lunar landers commercially, and and also other. I can see in the exhibition area, I can see a lot of moon landers, either those from the universities or from the private firms or from the national teams. So today is the right moment for us to coordinate our human space activities in the cislunar space, either in orbit or on the lunar surface. So because that we've already found water on the lunar surface, and also potentially in the future we can utilize the helium-3 to solve the energy problem of human beings. So it is very hopeful today we have the more and more chance to adopt the commercial style, a commercial manner in our space activities to provide all kinds of services to deliver goods to the lunar surface, or provide the communications or other services. So today, the lunar exploration is not only the business of national teams, but also more and more private firms engaged.
And Mr. Xu, how important do you think that is to have the private sector get engaged in this? I mean, what's the advantages that commercial space exploration has?
Commercial sectors can provide two aspects. One is financial support to the space program. Another is technical validations to the existing technologies, or maybe new technologies, demonstrations. But they also have a risk because Professor Yang mentioned about the space debris issue. We have roughly 100,000 objects orbiting the Earth orbit with diameter more than 1 centimeter.
100,000?
100,000 is already in orbit.
That
and also,
sounds like a lot.
We have also increasing number of commercial companies that is launching satellites to orbit with mega constellations. All three astronauts you can see on board, they have also the risk of colliding with space debris.
Yeah.
So one of the launching campaign has to do is to calculate the orbit, because they have modelized all the space debris, and they have to calculate very carefully the opening of the space debris so that the astronauts can travel to the station safely. And one of the prominent payload on board this mission, Shenzhou 19, is to install a space debris protection shield on board the station. This is going to involve EVA activities. Later on, we're going to see that installation. So that shield can protect in a degree of the bullet speed space debris hitting the station, damaging the station, leaking the station, or hurting the astronauts. So this is one area that we have to be very careful. As you mentioned about the sustainability of IC.
What would that look like? What would that space shield look like exactly?
I think it's like a bulletproof panels outside of the fuselage.
Sort of hovering outside,
One
or
moment.
with a space in between.
The final ignition time has formally released.
Yes, we've got 10 minutes to go.
4 o'clock, 27 minutes, and 31 seconds.
Yes.
So that's the accurate time for the ignition.
So
But
we're
it's very
looking
interesting,
at
that
almost exactly 10 minutes from now.
Yeah. you know that it is very interesting that the countdown to zero, the definition in China and other countries are different. In China, the zero moment means the ignition time, but in other countries, for instance, in US, the zero means the liftoff time, the liftoff moment. So it's different for several second interval. So you can always hear the voice during the launch of China when ignition in zero, and the ground team will report the real liftoff time.
So what we're seeing now, the 4:27:31, that's the ignition time.
So that's accurate.
So the launch will be a few more seconds or so following that.
So you won't see fire, after zero, for 1 or 2 seconds, and then there's a fire.
But
so a little
in
delay.
US, you can see the fire just before zero because the ignition is several hundreds ahead of the liftoff, and at time zero, it will lift off.
Is it very precise then, the amount of time? Would they know in advance the amount of time between ignition and actual liftoff? Can that be calculated in advance?
That's very important.
It has to be very careful because the liftoff time is what we call a root parameter. That can calculate. It can be used for a root reference for calculation of the orbit. So once liftoff, there is going to be announcement, the exact timing up to the milliseconds, what time the liftoff.
Exactly.
Yeah.
So then after we see the ignition, which was announced there, how many more seconds after that will we then see the rocket actually lift off?
Yeah.
Just 2 seconds. Okay. So it's not a big delay.
The ground team will report the real liftoff time, the real liftoff moment, accurate to milliseconds.
Okay.
Yeah. After the liftoff, there's a first announcement. You can hear from there's a parameters. It's going to be announced by the control. So there's going to be a series of numbers. So that number is going to be used for calculation of exact orbit in the coming future.
For instance, for this launch, there will be a voice called 起飞时刻动4时27分31秒497毫秒.
Would you like to give that to us in English?
Okay.
Professor Yang?
That's an example. So that called the real liftoff time is 4 o'clock, 27 minutes, and 31 seconds, and several milliseconds.
So that would be phonetically similar to
Yeah. So that's so every time the same style.
Yeah, but the cruise looks calm and firm, as they call it, and they're ready to experience.
They still haven't
two of them are first timers.
Yeah, they still haven't put their visor, the helmet on properly, have they?
So you can see Miss Wang Haoze sit nearest to the camera.
Yeah.
And already we can see maybe already her face mask has already her face window has already been closed, I believe.
Wait, she's the one that's at the bottom of the screen, or the farther one? She's the one at the far end, right?
To the
bottom of the screen.
Bottom of the screen. Yes, exactly. So as I mentioned, she is 03. Usually the flight engineer and all the payload experts sit in this position. And 02, as I mentioned, is Mr. Song Lingdong.
He's got the parachute button.
Yeah. To control, just not this time, just during the reentry half a year later. I hope he will also conduct a vertical landing.
Well, that would be impressive. It would be
that
something
would be
to remember
more
for him.
convenient for all the 3 crew members.
And especially for him being his first time up there and the first time return, if he get a vertical landing.
But horizontal, you can imagine you're being strapped by the safety belt to your seat, maybe face down.
Yes, exactly. Not very comfortable.
So if the vehicle, that there is a deviation between the center of his mass and a symmetrical axis. So because of this deviation, usually, in most cases, it will lie down. So that will be much more inconvenient for the astronauts.
So we're looking at some of the conditions right now at the temperature, 3 degrees only.
Yes, right.
But visibility, very low wind speed, right? 0.8 meters per second,
which
actually.
Is
that low?
Yeah. Actually,
good visibility.
it is deep autumn in Jiqian much colder than the night of Beijing. We can see Miss Sun Ye, the very, very sick clothes.
Yes, definitely. Yeah. So Yeah, 5 more minutes to go till ignition time. And what? Just talk us through what the astronauts will be experiencing during the launch before they reach orbit.
Parameters, and also maybe, as I mentioned, maybe they will already close their face masks, and also.
That's the 5 minutes countdown.
5 minutes and counting.
But the astronauts won't be able to see outside at the first stage, and then after the jettison of the escape tower and the fairing, they're going to have a little window they can see outside. Yeah, see the horizon.
The what calls the launch azimuth, or the flight direction of this Long March 2F is going to the east, and then a little bit to the south. So maybe at the separation of the second stage and the Shenzhou spacecraft, maybe they can already see the sunshine, maybe. And at that moment, they can have the light from the window.
And Mr. Xu, can you give us a sort of equivalent of what it would feel like to be an astronaut during this whole, after the liftoff, you know, especially with the G-force and everything, you know, what would it feel like to us, you know, if we can find something?
If you can imagine you're in a car, in a sports car, and you accelerate very quickly, it's like an airplane or even faster. Then you go vertically, but you're going vertically up with the acceleration, and then that would happen in the first, let's say, 10 minutes. The first 3 or 4 minutes, you get very quick acceleration, and there's what we call a max Q, the biggest time biggest stress that you can experience in the launching.
The biggest stress.
Yeah, and then there's also issues what we call a pogo. Sometimes it go up and down.
Oh.
And
vibration.
Then, vibration. It's a vertical vibration we call pogo. And then after like 10 minutes, and then there's a seize of the engine, and then you feel microgravity. You don't feel anything. It's like floating in space. So that's the whole process of launching, I think.
Usually, the thrust of the engines is a constant value. Okay,
3 minutes.
T-minus 3 minutes and counting. But you know that the propellants become less and less. So the acceleration becomes more and more. You can feel more and more G-forces. So that is very normal. So usually the max G-forces happen during the separation of the stage. So that is the reason.
And this pogo stage you're talking about, I guess that's why they need the seat to be so snugly
you can feel
fit
that
to
all
their
your organs
comfort,
will
right?
go out.
Yeah. It's like
to reduce the amount of space that you could be hitting against
it's
a
a
chair.
big suffering. Yes.
You know that Mr. Yang Liwei feels extremely uncomfortable because you know that the G-forces combines with the vibration together. This can never be simulated on the ground simultaneously.
So they can't really prepare for this then, you're saying? If it can't be simulated on the ground, can they
They will
train
have
enough for
trainings
this?
of the G-forces. They will have the trainings of the vibration. But
not
on the ground,
together.
they cannot be combined together.
So then
But
only these...
there's room for you improve the rocket itself and make it more smooth.
So really, only astronauts who've made the successful mission to space and back they're the only people who've actually can experience this movement, I suppose, of the launch. You can't replicate it here on Earth so far.
It's out of the Earth.
Okay, please notice it's already less than 2 minutes for the liftoff. And next, as I emphasized, some of the arm connected to the launch vehicle will be unplugged.
So all those umbilical cords, essentially. They're looking very tense there. This is the control center in Zhuquan.
We're going to have countdown at any time.
So we also have cameras mounted on these arms to monitor the separation position, the unplugged position. So today we have more measures than before to ensure the safety.
I wonder how nervous they're feeling. Okay, this is the 1 minute countdown now.
T-minus 1 minute and counting.
That means everything has to be in green light.
Nobody
has to press the red button.
Don't touch anything.
Yeah. The number of systems that has to work together.
But they're so practiced at this now. You know, they're so experienced with this whole process.
All the
40
arms
seconds.
untouched.
Thirty seconds to go.
So the transfer of power supply also accomplished.
The rocket
20
is on its own.
seconds.
Maybe the astronaut will salute.
Yeah, normally.
I feel the tension. 10 seconds. 5, 4, 3, 2, 1.
Salute. That's a report of the really tough time. And the tower is cleared now.
I counted as well after the ignition, about 2 seconds, yes.
So
That's it.
we
That's a long
already
March
have
carrier
a
rocket.
successful liftoff. After about 2 minutes, we will have what Yansu mentioned, the first separation,
Right,
the
we'll be
jettisoning
watching
of
that
the
in a minute.
emergency escape tower.
This you see is a strap-on booster.
Yeah, exactly. So this
The
is a
camera from the
camera
outside.
mounted on the core stage.
Yeah.
We can see 2 of the 4 strap-on boosters, 2 of the 4 side boosters. So as I mentioned, they each have 1 engine.
Looking
I
down.
think we're hearing,
Yeah,
really,
looking backwards.
It's a nominal tracking.
Now we can see that on the right of the screen is the camera mounted inside the re-entry capsule, and on the left is what the camera, as Yan Song, the camera mounted on the core stage, looking backwards.
so at this point they're not feeling so bad. It's when the boosters come
We
off.
have
they're saying
G-forces
that's
and
when-
vibration, not very
They're
comfortable.
accelerating. Yes.
And it became more and more worse because with more and more acceleration, with less and less propellants.
So it will get progressively worse. Right now is not the worst part.
There's a max Q. There's maximum time. You know.
Right.
You're in the transonic procedure.
So any minute now, I think we'll see the propellants come
The
off.
speed
right,
is
the
not
boosters.
still.
It is very interesting that maybe at this, maybe next ceremonies in Beijing, maybe on the top of this building, you can see the trajectory because it's very bright. And
We
it's
should
close to
get
Beijing.
outside.
You can see the trajectory of the second stage.
Now you can pay attention to the escape tower. It's going to be ejected anytime.
Exactly.
Yeah.
At about 2
It's gonna be
minutes.
a small fire on top of the rocket.
Right, looking at the very point of the rocket. Oh, there
okay.
it is. It just
Great.
went.
Jettison.
Yeah.
But still, we have rocket engines on the payload fairing. If anything wrong happens, we can still use the engines to separate the rocket.
The image on the right there that we saw was a simulation, was it? Or,
Yeah.
Yeah.
And now this is a real,
This is the-
real
yeah.
optical. Yeah.
Well, on the left of the screen is the infrared
Yeah.
video images.
Yeah. Next stage is the separation of the strap-on booster. You're going to see four
Yeah.
strap-ons are going to be
Four
separate at the same
light
time.
spots.
Yeah.
Okay. It seems
Looks like it's happening.
And this is when the
Yeah.
villagers will be
Separated. And
glad
then the
that
separation
they're
of the first
watching
stage.
a film
Yeah.
somewhere.
okay. The first stage also separated.
That is the announcement of the boosters having separated.
Yeah. So the rocket is on the second stage.
Yeah. Yes. And the next step will be the separation of the 2 payload fairings. At that moment, maybe the astronaut can enjoy the view.
Yeah. The separation of the fairing means you're out of this world now. And you're out of the atmosphere. And you have no drag
Do
from
not need the protection of the
Literally out of
aerodynamic
this world.
forces.
Yeah.
Now, this is a video get by the camera mounted on the rear part of the second stage. And this is a video inside the payload fairing. We can see the folded solar panels of the Shenzhou spacecraft.
Ah, and when that is released,
You
Okay.
see
the
the,
success-
Separated.
the
there
fairing's
we go.
gone.
The bottom right screen there.
Fairing's gone, now they can see the world.
But obviously, at this moment, the Shenzhou spacecraft is still in the shadow area of the Earth, so the
There's
astronaut cannot
not
see
much
the light of
view.
the sun.
Yeah.
But they can already view the beautiful Earth now.
They're checking their
It should be
manual
above
again.
Shandong at this moment.
Not yet, maybe 7 minutes later.
Yeah.
The separation point of the launch vehicle, the second stage, and the Shenzhou spacecraft will be to the east of the eastern coast of China Sea, maybe in the Yellow Sea area.
So it's all very precise where it's going at what time. You know, you can predict.
Everything is designed.
USB 雷达跟踪正常，遥测信号正常。
So
The
there's
USB
a-
reader works normally, and also tracking.
Nominal tracking, nominal functioning. So everything goes well now.
Yeah, and the astronauts are looking pretty comfortable in there, flipping through their manuals.
Now you
again.
can see that on the second stage we have 1 main engine and several vernier engines. The main engine has a thrust more than 80 tons. and the vernier engine to change the stability and also direction of the second stage. And the next step will be the shutdown of the main engine. But the full vernier engine is still working for several seconds to ensure the accuracy of the trajectory. Now you can see that's the second stage. Because it is at night, it's very bright.
Yeah.
This is a camera mounted on the end of the second stage, looking backwards.
So far with the Shenzhou missions, have we ever had a daytime launch?
I
With
think yes,
manned
we do.
missions? Manned missions?
Yes, we do.
The second stage works much longer than the first stage, although it has a shorter length, has less propellants, but because it only has one main engine, about 80 tons level, so it works much longer. Okay,
It's one of
Qingdao
the-
ground station
that's
has
one of
already
those.
have the data link connected to the launch vehicle.
So it's
But
near
this moment,
Shenzhou.
but this moment is still to the west.
Yes,
We're on
west,
track.
yeah.
Yeah. And then it will fly across the
Yeah.
Qingdao.
渭南 USB 雷达跟踪正常，遥测信
That's
号
Still
正
have
常。
connections with Weinan Station in Shanxi province.
That's my hometown.
Yeah.
Getting a good view there.
So you can visit the ground station.
So I guess it's above Hebei at this moment.
收取 USB 雷达
Maybe in
跟
Shandong.
踪正常，遥测校正常，东风飞行正常。
So after Shandong, it's going to be entering the Pacific, and then the boat will take over.
Our
for the control,
space
yeah.
tracking ship, our Yuanwang 3 space tracking ship.
So we can really draw out the map of exactly where this
You
rocket
can see
is
the
passing
bright
by
flame
now.
of the vernier engine, and also in the middle is the main engine, very bright. So the vernier engine can have a servo unit to move its direction to change the attitude of the second stage, and also to keep it stable.
What period of time are we looking at before they reach orbit?
About more than 9 minutes
More than 9
after
minutes.
launch.
So I think you can see that the engine is continue to accelerate the capsule so that it can reach roughly 7.8 kilometers per second speed, which is what we call cosmic speed for not coming back to Earth, but it's circling around the Earth. That's the minimum speed that they request to go around the Earth, and also they're accelerating to the altitude of which is a little less than 400 kilometers above the Earth, which is the station
冰岛
altitude.
飞船双补完成。
You know, we said earlier how they chose this time so that the whole rendezvous and docking, the whole process will take less time, 6.5 hours, right? Then what's the longest that China's manned space missions have taken then for this process?
For the Shenzhou, for the Tiangong 1 and the Tiangong 2 missions, usually we took 2 days.
2 days.
Okay,
that's
the main
a big
engine of the
difference.
second stage has shut down, which means that the main acceleration procedure is already been accomplished.
跟踪正常。
And the astronaut is now, the G-forces is much less than before,
Right.
much more comfortable than before. And then with several seconds will be the shutdown of the 4 vernier engines. You can now still see the 4 vernier engines.
Well, let's check in now with Zheng Yibing, who's at the Beijing Aerospace Control Center. Yibing, so everybody must be tracking the progress of the rocket there. What's the latest?
Shenzhou 19 spacecraft has been launched from the Jiuquan Satellite Launch Center, and we saw the exciting moment of the ignition and liftoff of the flight combination of Long March 2 FCAR rocket and Shenzhou 19 manned spacecraft. And this is the 14th manned space flight mission of China. And also, its mission is to send the Shenzhou 19 crew to China's Tiangong space station to take the baton from the Shenzhou 18 crew for the 6 month long stay in China's space station. And also here at the Beijing Aerospace Control Center, we saw the whole process of this launch sequence. From the see-off ceremony from the Wentiange Pavilion to the system check at the Beijing Aerospace Control Center, and from the counting down at the Jiuquan Satellite Launch Center to the separation of the boosters and the first and second stages. And while the 3 taikonauts, or the Chinese astronauts, just like the Mr. Yang Yuguang in the studio said, they look very comfortable. So Mr. Cai Xuzhe and So Lingdong and Wang Haoze, they look very calm and determined. They do prepare for this mission. And well, this mission, or the flight mission of the Shenzhou 19 crew, takes a fast rendezvous and docking mode, just like the previous 7 mission from the Shenzhou 12 3 years ago to the Shenzhou 18 just 6 months ago. They all took the fast rendezvous docking mode. It took about 6.5 hours to get for the spacecraft to get to the Tiangong space station. So now at the current time, we saw on the big screen is the status of the Shenzhou 19 crew, but in the moment later we are going to see the Shenzhou 18 crew. They're waiting in the China space station and waiting for the coming of the newcomers to the station. And during the recent days, they have made a very full preparation to welcome the newcomers. And we're going to see the meet and fantastic meet, the space meet of the 2 Shenzhou crews in China's Tiangong space station. Although this is a routine launch mission after China's space station entered its application and development stage, we all see the details. We also see that is very exciting moment. Just like the crews of the Shenzhou always said in the China space station together, China's space is always worth looking forward to. Back to you.
Yibing, thank you so much for being at the Beijing Aerospace Control Center.
Just during Yibing's description, we've already seen the successful separation between the end stage and the Shenzhou spacecraft. And now you may notice that the Shenzhou spacecraft is already in the sunshine area. You can see the beautiful curvature of the horizon of the Earth. Very beautiful.
This is the camera outside the capsule.
Yeah.
And so soon we'll be expecting the solar panels to open up, right?
Unfolded, will be extended within several minutes.
That marks the success. Yeah.
Although we don't usually hear the announcement from the control center of the official,
the commander of the launch site system. Now you can see the camera on the propulsion module, which can monitor the unfolding procedure of the launch solar panels.
We just heard some various reports there.
And also, as I emphasized, you can see the beautiful curvature of the Earth's horizon. Okay, unfolded. Each of our solar panel wing have 4 pieces, the Shenzhou spaceship.
How many solar panel wings does this have?
2 wings. Each have 4 pieces.
And then we can see the Shenzhou 18 crew in there eagerly awaiting. So we expect the 2 crews to meet by midday Beijing time, right?
Exactly.
Meet for lunch.
The 5th
lunch dates.
The 5th rendezvous of different crew in orbit.
Yes, the capsule itself has to find the sun so that the solar panel can be driven by a system called SADA to face the sun to generate maximum power to provide the capsule with electricity.
It finds that automatically?
Yeah, it has a sensor.
And the orbit maneuver to chasing the Tiangong space station will all be done automatically.
We're hearing that they're saying the panels are rotating normally.
Ground staff report, as Yan Song has mentioned, the SADA working normally. Tianlu is the name of the Tianlian data relay satellite.
We're talking about the tracking there.
Yeah. Now you can see it's already in the daytime. You can see the Earth is so bright.
Oh, I was wondering what that was actually. I wasn't sure.
It's already above the Pacific Ocean.
They find the sun.
Sunflowers.
So it's another day for them.
That's the Shenzhou 19 crew speaking to the command center. Oh wait, the other way around.
The voice of Mr. Cai Xuzhe.
Report on the health conditions.
That's the Shenzhou 19 crew speaking.
Feeling good.
That's a classic line, isn't it? Yeah, we're feeling good.
Obviously, he's very calm.
神舟19号，经地面确认，座舱环境正常，可以打开面窗。
Is this the little window that there's that
they can open their face mask.
they can, okay.
Because this moment, the inner atmosphere inside the cabin is in a normal condition.
There, they just open it
not
up.
hazardous to the astronauts.
What sort of temperatures is inside this capsule right
in
now?
room temperature, usually very
something.
comfortable for them. Maybe 20, maybe 25 degrees.
Yeah.
But when they open up the that helmet, the visor, would they feel a change in the pressure?
No.
No?
It's adjusted to the human adapted conditions. Yeah. What we call life support system on board the capsule.
Okay, both the space tracking ship Tiangong 3号 or the Yuanwang 3 tracking ship, and also the Tianlu or the Tianlian data relay satellite have normal communication link with the vehicle. So we have redundancy measures, both from the sky and from the sea.
So this view we're looking at right now on the screen, so this is a camera launched from
mounted on the Shenzhou spaceship.
And that
Outside.
bright orb is
the bright
sphere
one
is
on the top right is the Earth.
That's
With cloud.
really fascinating view.
Maybe it's alright, not cloud. Maybe it's because
White
it is
color?
too bright. It's
Yeah.
just because it's too bright.
Yeah.
That's not a view everyone gets to see.
It is over exposure of the camera.
I hope we can go there and see it.
Maybe with these privately, operated spacecrafts.
You will be the fifth batch of
As Sun Ye was saying earlier, that the frequency of these launches now, these manned missions, every half a year. This is it's impressive, isn't it?
Yes, to maintain the permanent presence of human beings on board the station, you have to do that in rotation every half year. But astronauts do have longer times they stay in the station. One of the longest one, an American, spent almost 2 years in the station. But when he came back, he said, I went to a foot massage. And the foot massager said, I've never tried a foot so tender.
Wow.
Now is a video. Oh, this is a 3D animation. So you can see, although it is a 3D animation, but it is real data driven. So the status, including the status of the panels, represents the real condition.
实时轨道与遥测数据监视判断，神舟19号飞船已进入近地点高度200公里，远地点高度362公里，倾角41.5度，周期1小时30分钟的预定轨道。太阳帆板展开，飞船工况正常。
The spaceship is operating normally, the astronauts are feeling good, the panels are open, operating well. Pretty much as expected, everything just went.
With that apogee and perigee, it's in elliptical.